So in this video, I want to explore using replicate what happens as I select different validation sets. So I again have my get correct classification rate function. That's like that. So I predict for data and I compute the performance. And now I have my get valid performance function. So what it does is it takes a new sample of IDX, so takes a new training set each time of size 500, and it takes a new validation set each time of size valid size. So here it's like IDX 501 up to 501 plus valid size. So that gets me valid size rows, some random rows that are not also in the training set. So now I'll make my model like this, and I'll get my, using the training set, and I'll get my correct classification rate on the validation set. So the reason this is kind of interesting is that the performance on the validation set, that's supposed to be kind of a proxy for the performance on new data. So it's kind of important to know whether this is reliable or whether for different validation sets I'll get kind of completely different things. So okay, so I'll do get valid performance, and now I'm doing this. So I'm saying replicate 1000, and for a validation set of size 250 I'll get the performance every time. So it's going to be a different training set every time and a different validation set every time, right? So it's interesting to see whether I'll get the same thing every time, which you'd expect if you have a really large training set and a really large validation set, or whether you might get a different performance every time. So this just gets me the performance on the validation set for this kind of experiment, okay? And here I'll just have kind of one column that's going to be the validation performance. So okay, let me run this. Okay, so now let's see what I get. I got that ggplot is not there. So this is my histogram, and what you see might be a little bit surprising, right? So what you see is that the performance with the same procedure, right? You select 500 for the training set, you select 250 for the validation set, and the performance can vary quite a bit. So you might say, well, this could be due to two things. It could be due to the fact that the validation set that you select every time is not necessarily representative, or it could be due to the fact that you're selecting a different training set every time and that's not representative, so the performance of the training set is not the same every time. So we can try to see which one of those it is. So one way to do it is to say, well, we'll select the same training set every time, but we'll select a different validation set every time. So I'll do this. So I'll make another function. So that's going to be get valid performance fixed trained or something. So because we fixed the training set. So how can we fix the training set? Well, we can say the training set is always going to be IDX 1 through 500 for a set IDX. So I'll do set seed 0. I have to do it outside, of course. So I'll do set seed 0 here, and I'll get my IDX over here. And I'll say that my train IDX are just IDX 1 through 500. So that's fixed, and here I set seed 0. That'll just run the ones. I'll get some train IDX. I can know which one they are right now, so those are those train IDX. Okay, so now I'll say the rest I'm gonna get a different set every time. Okay, so I'll say I'm gonna give train IDX, and now I'll have the rest of the IDX. So that's gonna be IDX 501, and that's gonna be through the length of IDX. So the length of IDX is like 800 something, 887. So train IDX and rest IDX do not overlap, they're different. And now when we're selecting the validation set, we'll select them from rest IDX, but train IDX is going to be the same every time. So now we also need to give this IDX. So here it's not like as apply, it doesn't matter the order. So I'll just say train IDX is like this, and rest IDX is like this. And now Titanic train is now just going to be train IDX every time, and we're going to give the same train IDX every time. And now what we got to do is we got to say, okay, so valid IDX, we're going to again sample from rest IDX, so we reshuffle rest IDX every time, and we go from 1 and up to valid dot size, like this. So Titanic valid is now going to be valid IDX. So I want to kind of reiterate what I'm doing here. So train IDX is the same every time, and then valid IDX is sampled from rest IDX a different way every time. So we make a permutation of rest IDX, and we take in the permutation from the first element until element number valid size. That's going to be a different thing every time we call get valid performance fixed trained, and from here on we'll do the same thing. So okay, so here we'll say replicate again, we'll do 1000 times, we'll do fixed valid performance, and then get valid performance, and this is fixed trained, like so. And here we'll keep 250 for now. So 250 is valid size. We also need to give it train.idx, and we need to give it rest.idx, so the indices that do not overlap with train.idx. So let's try this. So need to wait a bit. So we can now display the results. And this still looks like that. So as you see, we have quite a bit of variation. So that kind of does have some implications, although not as much as you would think, for what we were doing before. So what we were doing before is we were selecting kind of which model to use based on the performance on the validation set. But as you see, kind of with exactly the same settings, the performance on the validation set of size 250 can vary quite a bit. Now, if you make the validation set a little bit larger, so let's see what the length of rest IDX is, 387, you'll get a little bit less variation because, of course, now you'll get no variation at all because you're selecting the same set every time. But if you select like 300, again, this is kind of getting to the point where, well, the reason you're getting the same performance is you're selecting the same thing every time. But it's kind of interesting to see what you'll get. So I ran it, and now we can see what we get. So we get quite a bit less variation. Well, in part, this is just because we don't have very many indices to select from for rest IDX, so of course we're selecting the same every time. You can go the other way, so you can just say I'll select 50 every time, and now you expect to see a lot more variation. And indeed you do. So here you see that you get like performance that's as low as 0.5 and as high as 0.8.